Hello and welcome to Algebra 2, Chapter 11.4, and today we're going to discuss infinite geometric series. So remembering that series means we're adding them together. Geometric means that there's a common ratio, so every time we're multiplying by a number. And so these are infinite ones. So if there's no end to my series, what is their sum? Well, let's talk for a minute. Before we talk about this one I want to give you another one. What if we start at 1 and every time we multiply by 5? So we'd have 5 times 5 times 5 times 5. If I continue to do this and I added them all up forever, what would they eventually reach? Well, it should reach infinity because there's no end to that. It's going to keep getting bigger and bigger and bigger and bigger. So the flip side to that is, what if I multiply by a fraction? So let's refine that. What if I multiply by a number between 0 and 1, that kind of fraction? And so here I'm multiplying by a half. If I do that forever, will it eventually reach infinity? Each time I'm adding a smaller number and a smaller number and a smaller number, and the answer is no, they don't reach infinity. So if you look at it here, if I add these two together, I get 0.75. If I add that to an eighth, I get 0.875. If I add that to a 16th, I get 0.9375. So if I add 1/32nd, I would get 0.96875. If I add 1/64th, I would get 0.984375. If I add 1/128th, that would equal 0.9921875. If I add 1/256, that's 0.9960935. Okay? Do we think on this pattern I'm ever going to get to infinity? No. What am I going to get to? What is this approaching? This one is approaching 1. Okay, so we have a special formula for it. If we're talking about an infinite geometric series, its sum is a sub 1 over 1 minus r. But the thing is, this only works if the absolute value of r is less than 1. So if your common ratio is something between 0 and 1, but it could be positive and or negative. So let's look at a few. Find the sum of these infinite geometric series. So you just wrote down s equals a sub 1 over 1 minus r. So this is going to be s equals, well, we have to know our first term. So if let's see here, if I put in a 1 minus 1, 1 minus 1 is 0. So 0.1 to the 0 power is 1. Anything to the 0 power is 1 times 2 is 2. So my first term is 2. 1 minus, so what's my r? Well, if we look really closely, remember that a sub n equals a sub 1 r to the n minus 1. So my r is this value right here, 0.1. So that's 2 over 0.9, and we do not leave decimals inside fractions. So a quick fix for that is I need to move the decimal over 1, so that's a times 10, so times 10 times 10. That is a 20 over 9. That's what that's going to approach, or that's what the sum is going to be. When I say approach, if you graphed it, that's its asymptote that it's getting close to. So the next one here, s equals the first term, 12 over 1 minus, what are we multiplying by every time? We're multiplying by a third. Okay, because essentially we're dividing by 3 every time, so we're multiplying by thirds, so that's 12 over 2/3, which is 12 times 3 halves, which appears to be 18. So you add all those up, you're going to get 18. One more to look at. So what if it gives you the sum and it wants the common ratio? Well, you just plug it in. So a sub 1, 1 minus r. So my sum is 27/5. My first term is 5, 1 minus r. I would probably cross multiply. So 27 minus 27r equals 25. Subtract the 27, you get negative 27r equals negative 2. Divide by negative 27, r equals 2/27. All right, so that's what I have for you for today for 11.4. There is also changing irrational decimals, or I should say repeating decimals, into fractions. And so we'll discuss that in class. And if you have any questions, let me know. Have a great day.